Alright, so there are 4 ways to solve for quadratics. And one, we have the quadratic formula, which you use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what you have to do is you have to simplify your equation into standard form so you can get your a, your b, and your c and plug them back into the quadratic formula to solve for your answer. Now, the second way for solving for quadratics is completing the square. And you use this formula right over here, which is b over 2 squared. And once again, you have to put your equation in standard form so you can get your a, your b, and your c. And then you can use this little formula here to help you solve for the rest and get your answer once again. And the third way to solve is factoring. And while you factor, you want to get this value. So you want to get the value of b, but in order to get that, you have to factor out, you have to see how many factors go into the value of c. So the two factors that you add together to get b are the factors that you would use, and you would use the zero product property and plug those in to find your x values and get the answer once again. And then the last way is by graphing, and once again, you have to put it in your standard equation, and you mainly use a calculator on this, and I'll show you later on how to graph with your calculator. Alright, so while you're graphing, you want to make sure that, of course, your calculator's on. So once you turn on your calculator, you're going to hit Y1, you're going to hit second Y1, and you're going to put in your equation that's in standard form. And then once you have that, you can hit graph. And now I zoomed in this graph a lot because we're going to have to find the vertex right now. So what we're going to do is we're going to hit second, and then we're going to hit trace, and you're going to scroll down to minimum because this is a minimum graph. So you hit enter, and then it asks for left bound. So you're going to scroll to the left of wherever this vertex should be. So this looks like it'd be left of the vertex. And then you're going to scroll to the right when it asks right bound. So you scroll to the right and hit enter, and then it asks guess. So you hit guess, and it's guessing that our vertex is at negative 26.5 and negative 1,332. So that's our vertex on our graph right here. And now we have to find our x-intercepts. So what we're going to do is we're going to go back to this, and I'm going to have to zoom out a bunch. So you zoom out, but when you're doing the x-vertex, you basically just do the same thing, except on the x-axis, and you have to, what you do is it asks, when you're on your calculator, you're going to go to second, and then you're going to go to trace, which is calc, and you're going to scroll down to number 2. And then what it asks is it says left bound of this line right here. So you're going to go left bound, enter, and then you're going to go right bound, enter. And then it's going to ask guess, and it will give you negative 63. And then you're going to do the same thing for the other side, and it'll give you 10, and then that's the answer to your equation. Those will be the final answers, and these can also be, x-intercepts can also be zeros of a function and solutions. Okay, so for imaginary numbers, you basically just distribute, but you don't distribute you distribute this to this equation right here. So if it's when you're using addition or subtraction, you would distribute the positive or negative sign to these two. So if we distribute, the equation then becomes negative 2 plus 3i plus 7 minus 6i, because a positive plus a negative is still a negative. So then after that, we can add up like terms. So negative 2 plus 7 would become 5, and positive 3i minus 6i would become 3i. And this is in standard, this is a complex number in standard form. So it would be, the equation is a plus bi, where a equals 5 and b equals negative 3. But when you use multiplication, it's different, is you FOIL out the two separate equations in parentheses. So you FOIL both of these together, and then that would become negative 20 plus 35i minus 24i plus 42i squared, and I squared equals negative 1. So that becomes negative 20 plus 11i, because you add like terms as well, add or subtract. So it becomes negative 20. So when adding imaginary numbers, you distribute whatever sign you have. So we're adding, so we're going to distribute this to the 7 and the 6i. So that then becomes negative 2 plus 3i plus 7 minus 6i, because a positive times a negative is still a negative. So then if we add like terms, so negative 2 plus 7 equals 5, and then positive 3i minus 6i would equal negative 3i. So this is your final answer right here, is 5 minus 3i, and this is a complex number in standard form, and this is a plus bi, where your a equals 5 and your b equals negative 3. Now in subtracting, we do the same thing as addition. We distribute this sign to these two numbers. So a negative times a negative equals a positive. So I just see it as like that, as you turn in the two negatives into a plus sign with the parentheses. And then same here, a negative times a negative is a positive. So our new equation becomes 9 plus 3i plus 2 plus 7i. So once again, we can add like terms. So 9 plus 2 would be 11, and then 3i plus 7i would be 10i. So this is in our complex number in standard form, so a plus bi, where a equals 11 and b equals 10. Now when multiplying, we're going to do something different. You're going to have to FOIL it out. So we're going to FOIL the 5 to the negative 4 and to the 7i, and then the 6i to the negative 4 and to the 7i. So our new equation would become negative 20 plus 35i minus 24i plus 42i squared, because we have this 6i times this I, and an I times an I would be squared, just like x times x would be squared. Now, when you have I squared also equals negative 1. So to make it easier and cancel out a variable, we can just plug in negative 1 for I squared. So our new equation would become negative 20 plus 11i plus 42 times negative 1. And a negative times a positive is a negative. So our new equation is negative 20 plus 11i minus 42. And then once again, add or subtract to like terms. We end up with negative 62 as our a value plus 11i as our b value. So for falling objects, our equation would be h equals negative 16t squared plus s. And for thrown objects, our equation would be h equals negative 16t squared plus vt plus s, where h equals the ending height of the object after it falls, v equals velocity, t equals time traveled, and s equals starting height of the object before it falls. So the question is to throw, or what we're doing is we're throwing a horseshoe with these terms. The initial velocity of 30 feet per second, and it leaves the thrower's hand 4 feet above above ground level. And it lands on a stake 1 foot above ground level. So what we did was we drew this right here. So it leaves his hand, just imagine his hand is right here at 4 feet, and then it lands 1 foot above the ground. So the questions that we have to answer are what is the max height and how long did it travel before hitting the stake that is 1 foot tall, and how high is the horseshoe at 0.5 seconds and at 1.5 seconds. So what we're going to do is we're going to rewrite our equation, and this is for a thrown object, so we're going to use a thrown object equation. So we have 1 equals negative 16t squared plus 30t plus 4, because we know what the starting height is, and that's 4, and the ending height is 1. And we know what the velocity is, which is 30 feet per second. So with that equation, we have to put it in standard form, so we have to make it equal to 0. So we subtract 1 from both sides, and we get 0 equals negative 16t squared plus 30t plus 3. So we're gonna draw this graph right here, and we're gonna have to find all these numbers using our graphing calculator. So using our graphing calculator, we're gonna want to turn on our graphing calculator first of all, and you're gonna want to go to y equals, and you're gonna type in your equation in standard form. So we have negative 16t squared plus 30t plus 3. Now we're gonna hit graph. There's an error. So after fiddling with the zoom button or changing your window, your graph should look like this. And right now we're gonna have to find the vertex so we can see what the maximum height is of the thrown object. So to find your vertex, you're gonna go to second trace, and this is a maximum because it's a max point instead of a minimum point. So we're gonna hit enter on maximum, and then it's gonna ask us left bound. So you're gonna wanna go anywhere left of the vertex, where you think the vertex is gonna be. Now the vertex, we all know, is gonna be down the center. So I went left of that point, and now it asks right bound, so you go right, and then hit enter, and then it asks guess. So you click guess, and it's guessing that our vertex is gonna be at 0.93, or 0.94 rounded, and then y is going to be at 17. So our vertex is going to be 0.94 comma 17, whereas 17 is going to be our max height of our thrown object. So that's the answer to number 1, is 17 feet. Now it says, how long did it travel before hitting the stake that is 1 foot tall? So what we're going to have to do is we're going to have to go second and calc, and we're going to have to find the zeros now. Finding your zeros, you're going to want to zoom into your graph like this so that you have both sides of the x-axis. So when finding your zeros, you're going to hit second, and you're going to hit trace, which is calc, second calc, and then you're going to scroll down to 0 and hit enter. So we're going to go, let's see where this is first. Where's our little spider? So to find how long it took to travel before it hit the stake, we would have to find our zeros in our graphing calculator. And to find the zeros, you would hit second, and then you would hit calc, which is also trace. It's the trace button. And then you would go to zeros, and it would ask for left bound of the x-axis. So you would click left bound, and then you would click a point there. Then it would ask for right bound, and you would click a point there. And then it would ask guess, and you would click enter, and you would get 2 zeros. These are the zeros that we got, the zeros of a function, solutions, or x-intercepts. Now my graphing calculator isn't like working right now, so I'm just explaining this. But with these 2 zeros, this one is the farthest to the right because it's a positive number. So this is the max time. This is how long it took for the object that was thrown to travel from here to here. So that is our answer for number 2. And then what you have to do for how high is the horseshoe at 0.5 seconds and at 1.5 seconds is you would, on the calculator, you would hit trace, and then all you would have to do is you would just type in these values, and it would have x equals 0.5, and it would tell you exactly what the y value is. So this is what the y value would be for 0.5, and this is what the y value would be for 1.5, and that would be your answer in feet.